we're going to do motor starters tonight. Motor starters, we did the theory last week. This week, we're absolutely going to look at the calculations. Guys, the calculations is always the part people think it's the hardest. It's not the hardest. It's absolutely, if you practice it, it becomes easy. But what I want you guys to do is learn how to use the formula sheet when you do motor calculations. All my calculations I'm going to do tonight, I'll refer to a formula sheet, and you must learn how to use your formula sheet. If you don't have one, ask me. I'll email it to you. I did email it to you guys on night number 1. If you haven't received one, I'll resend you one. So anyway, a couple of rules before we start. You need to know what the very important part of this whole process is. For instance, a transformer star connected load. You must know the connections. You must know where you can get voltage. You must know where you can get all the lovely things involved. So it's very, very important to know where you can get voltage and current from. So if I look at the star connection, there between line 1 and line 2, line 1 and line 3, and line 2 and line 3, you will get something. We call that what? Line voltages, V line. The voltage between a coil or across a coil is called V phase. Is it the same? I don't know. Let's have a look. I know, but I want to show you. If you go to the formula sheet and you go to star connection, there it is. It tells you the relationship between the coil and phase voltage. So there it says V line equals V phase times √3, etc. Now, if I say that, then all what I want to share is 230 times √3, give me 400. If I look at the alternative one, the one which is written on here, if you've got 400, all what you're going to need to say in this case is 400 divided by √3, give me 230. Right, guys? Sorry, I just want to tab in here. All right, there we are. I just want to get Tracy in. Right, there we are. Cool. So very important for you guys is to know that this little star block is critical when it comes to your type of questions. Now I'm going to go back. I'm going to say to you guys, there's V line, there's phase. You must know that line and phase voltage is not the same. See there? Yeah, it's between line 1, line 2. Yes, line 1 and a neutral. Okay, say a star point, because a motor hasn't got a neutral. Line 2 and a star point, line 3 and a star point. Now there is your formulas. Now, the current flows in the line is called line current. The current in the coil is called phase current. The current in the line is line current again. As you guys can see, the current is the same. So we call this line equals I phase. There it is at the top. Or you can say I phase equals I line. So guys, it is not hard. That part is very, very important. But it's technically more important when we do transformers next week. For motors, not critical, but you should know the difference between line and phase voltages, because it all depends on the formula we're going to use. So guys, if anyone got a question, just put up your hand. There's like an icon. I'll see it on my cell phone who puts this icon on, and then I will just answer your question. Right, any questions so far? Right, I just want to get someone else in here. Ryan and William. Right, to carry on, yeah. What is power? Power is the energy used in this installation. The part picks up now as we will get all the power formulas. Please have a look. P line, depends if you want to use line or phase voltages. There, V line, I line, cos theta, power factor. That is your input power. If you want to use output power, √3, V line, I line, cos theta efficiency. Now that formula is not always given on this part here, but if you have a look at this one here, P equals root 3 V line I line cos theta. That formula is your input power formula. We're going to go through all those formulas, but I want to share with you. There is your input formula. Your output formula is not there, but you must know that you add the word efficiency to it. Now, if you want to use coil voltages, phase voltages, then what you do is V phase, I phase, coil voltage, coil current, roots are your power factor. But because there are 3 coils and all 3 coils is the same size, we will then say times 3. Because when it comes to a motor, all motor coil resistances is the same. So we will have a balanced load all the time. So very important to know about these formulas. Where can I find this third one? Right, guys, if you go here, it says 3 times V phase, I phase, cos theta. Take note, there's a difference between the two. The top one is line values, for instance, 400. Phase is your 230. Just know there's a difference between the two. Right, guys? So there's a formula. The 2 you will always use in a star connection, or 3, 4, depends which one you want. We're going to go step for step through all the possible formulas and questions they can ask you. And at the end, we're going to practice some. And then when we're going to start practicing some, you guys are going to then start answer the questions for me, and we'll see how we go. Right, let's look at the delta connection. A delta connection is very similar. However, that one looks like a star. This one is a triangle, a delta connection. If you remember last week, I said to you a motor can be connected up 3 phase 2 ways, either in line, either in star or in delta. If I take a motor and I connect it in delta, the voltages between the lines is called V line. The voltages across the coil is called V phase. And what's quite interesting, they are the same. But how do I know that? Bring up the formula sheet, go to delta, and there you see V line equals V phase, and V phase equals V line. That's interesting. But now what is different? So if you look below it, your currents are different. So the current in the line is not the same as current in the phase. Your phase current is different. And then the coil current or phase current, and when it comes out is the line current. There's a formula for that. And again, the formula is I line equals I phase times root 3, or I phase is I line divided by root 3. Remember, the line once is the bigger value. So anyway, power, exactly the same formulas, either V line or V phase. Depends which way you want to work it out. There's no law to say, Bradley, Alex, Dexter, anyone who's listening, that you must use either one of them. I don't know, but it's up to you which formula you want to use. Learn the line one, because the line one is the easiest when it comes to motors. Right, let's take this all, park it, and let's look at the nameplate of a motor. If you look at the nameplate of the motor, there's quite a few important things which pops up. It's all the parts which you must recognize when you're going to do, when you look at the motor in real life, but also to pass this exam. In the exam, they can either give you a question where they put values on a piece of question, or they can give you a nameplate and say, calculate the power. Now, anything on the motor nameplate, the power is called output power. There is a formula for output power. Root 3 times V line, I line, cos theta, which is your power factor, times efficiency. What is efficiency? Efficiency is the losses between input and output, the percentage effectiveness of the motor. Now, when it comes to motors, there are 4 losses, if you can remember last week. Copper losses, iron, iron losses, windage, and friction. Now, let's go back to iron losses. Iron losses is divided up into eddy currents or hysteresis. Now, That type of ones is just the losses we can get in motors. Now, very important, I will always give you the output power on the nameplate, never the input of it. So remember now, the input, the output. Input will be calculated, output will be on the nameplate. If I give you horsepower, horsepower is equivalent to output power, but we have to transpose or change it from horsepower to input power or output power. The answer is output power. Right, so in this case, output power is 4 kilowatt. Horsepower is 5.36. How can we take the 5.36 and get 4 kilowatt from it? Right, guys? You multiply 746 with 5.36. So if you take your calculator, you'll be able to see it quite easy. So very, very important. So anybody, take your calculator. Oh, bugger. Someone is calling. Let me just find out. Could be a trainee. Yes, I can help you. Yes. Yes, sign in. If you can sign in, sign in. I'll join you. You cannot. Okay. Okay. I'm recording this whole session. I'll send to you afterwards. You will not. Okay, I'll do. What's your email address? Okay, give me one sec. Gentlemen, ladies, just give me one sec. No, I have to go out of everything to get you in.
هذا قاعد دول.
Give me one sec. I have to go out of the whole because everybody's listening on the internet. Give me one sec. Sorry, guys. Okay, Graham, you're 100% right. Power is always measured in wattage, and input power or output power is always in wattage, regardless. And input power, output power is a difference. The difference is the efficiency of the motor. In other words, the percentage effectiveness of the motor. Right. Right, guys, sorry. Okay. Listen, guys, I'm just going to pause this computer because for some reason I can't move even my own thing now around. Fainted. Should be right. Okay, everyone stay online. I'm just going to restart my computer. Hang on. Right, what is your email address? There we are. We're back. Felicity, Liam, cool. I got you all back. Sorry about that. I don't know what happened there. Cool. Let's carry on where we were. I apologize for the delay. And I'll just quickly go to my PowerPoint. Can you all see anything? I don't think so.
No, not yet.
Okay, I'm just going to re-tab you guys. I apologize for the gremlins. There we are. Back on track. Anyone? Can you all see?
Yeah, that's better.
I believe so. Great stuff. Right. Anyone just to say yes, you can see the PowerPoint?
Yes, I can see.
Yo.
No.
Yes, well done, Jesse. Thank you. Right. So very important when it comes to motors. But very important about the motors. Oh, guys, give me 1 sec. This trainee still can't log in. Where's my emails? Give me 1 sec. I'm just going to go out. Bum, bum, bum. Now you guys can see all my stuff. Bum. Right, there we are. Sorry, guys. It's just unforeseen problems we had, but I should be sorted now. There we are. Right, let's rock and roll. Everybody can hear me. That's cool. I'm just going to go out so I can see your answers when you're going to type it in. Right. So, guys, very important. Output power will always be given on a nameplate. If you want to convert horsepower to wattage, please remember 746. 746 times the 5.36 should give you about 4,000. Can anybody just type that in on their cell phone or on their calculator? 746 times 5.36. What do you guys get?
3998.56.
There we are, 399.8. Well done, Jono. So, Jonathan, if you get that answer of 3,998 in the exam, if they ask you to type it in, type in 3998.56. If they give you 4 answers, choose the closest one. Anyway, so guys, we're going to learn how to work at output power. We're going to learn how to work at horsepower. The part coming up now is called efficiency. There's a formula for that. And by the way, you won't believe this. All those formulas is hidden on your formula sheet. We must learn to find the formulas. Now for efficiency, it's output divided by input. It's give you efficiency. It's like a funny NJ. That is the acronym. Now, what is the formula for output power? Well, we all know root 3 VI cos theta efficiency. But what is the formula for input power? This is the one on your nameplate. On your formula sheet. So that is root 3 VI cos theta. Please take note, the word efficiency is not there because that is output power. So there is the 2 formulas, output, input. Please take note of the 2 formulas. You must know the output formula because they will always love to ask you that because they know it's not on the formula sheet. But anyway, let's have a look what else we're going to work out through tonight. The part which is flickering now is called the speed of the motor. It's an RPM. Now that speed they give you is your rotor speed. Please take note, not your synchronous speed, because synchronous speed is the speed in which the magnetic field rotates in the stator. Rotor speed is the speed in which the physical shaft will turn. Now please take note, the formula slip is synchronous speed minus rotor speed over synchronous speed. You must know what they are. NS is your synchronous speed. NR is your rotor speed. 99.99% they will always give you your rotor speed. You will have to calculate synchronous speed to work out slip. What is slip? Slip is the difference in speed between the rotor and the stator, the fast one and the slower one. Now let's have a look. What is the formula for synchronous speed? Synchronous speed is frequency times 60 divided by pole pairs. And I'm going to say it again, pole pairs. Not pole, not just poles, but the pair of poles. The formula sheet doesn't say PP. The formula sheet says just P. So be careful when you get this one in the exam. So remember the word pole pairs. So there is also some more we need to know. The part which is flickering now is your frequency. In other words, in New Zealand, it's a norm to use 60 hertz. But in the exam, they might give you a question where they will say, the frequency of a generator is 70 hertz. What is the synchronous speed? In that case, then you have to use 70 hertz, but depends on the question. So guys, there we are. A little bit more, then we're done. So 3-phase means root 3, 1.73 on your calculators. If you don't know what 1.73 is, type in root 3 on your calculator. If I carry on, there's the 3-phase formula, and there's the 3-phase formula. If it's a single phase formula, please take note, there is no row 3, and in this case, if it's single phase, it will just be your voltage times your current. So this could be a 230 volt motor. But if you use phase voltage, line voltage, remember to add the 3. But that is just an example of a 3-phase motor. Now there is the input power, single phase formula. Right, guys, the one which is flickering now is your power factor, your phase angle between the current and the voltage. That is also in your formula. We just put in 0.8. Don't write in cos of 0.8. Don't confuse you. 0.8 is the formula, is the value. You type in 0.8. Something important as well, if you have a look at the 2-year, power factor is always given in a decimal point. Efficiency is always given in a percentage. Imagine both was a decimal point, then people wouldn't have known what is the difference. So anyway, that's nice to know. And then you are a bit brighter because you know, hang on, power factor is like that. Efficiency is a little bit different. Sorry guys, someone is stabbing in the door. Oh, Kylie. Right, to continue with the slideshow. Sorry guys, let me just get it. Yeah, where is it now? There we are. Is to work out the IP rating. Now, if you don't know what is IP rating, IP stands for the ingress protection. In other words, this motor is specially designed for a certain area. The first number 5 represent the penetration of any hazards. Could be a finger, could be a rock, or could be even dust. The second number 3 is the degree of protection for any moisture. For those who's got AS NZS 3000 with him, have a look at the back of the book, Appendix G. In Appendix G, IP rating is put out quite nice and clear for you all. You will be able to find it over there. Now, to carry on with this, we want to know how the motor is connected. So if this motor is connected in delta, it will tell you how the terminals must be shorted out, and it will give you the current and the voltage for this calculation. So that is quite important for you all. Let me just see if I can admit this trainee. Right, where are the details? Sorry guys. Right, I don't see anyone. Right, let me go back where we were. So what's very important for you guys is to know that any trainee who needs to work out how the motor is connected, please take note that it's either star or delta. Now this case, the motor is connected in star or delta. Can anybody just have a guess for me? Right, people's typing. If I give you the triangle, can anybody tell me if it's star or delta? Just type or just talk to me on my phone. I can be able to hear you. Well done. Great guys. Tracy, Brady, all you guys.
Delta.
It is connected in delta. Right.
Delta.
Sorry, it's a guest. I can't take people in which is a guest. So very important. The last part is the motor is not connected in star because it's very important to know that in star, the motor is not connected because there's no detail there. Graham, can you see the screen? Can you all see? Okay, well done, Graham. Sorry about that. So, guys, and the next part is torque. Torque is the strength on the shaft. If I say to you this motor is a 26.52 Newton meter motor strength on the torque, there's a special formula for that. And there we are. Power output equals 2 pi nRT over 60. So what is a very important part for you guys, is that T is torque. NR is your rotor speed. PO is your power output. And then 2 pi is the standard. Please take note, there's a possibility that you have to transpose the formula. And please take note, it happens at a lot of times that you have to learn how to transpose a formula. Now, this formula over here, 2 pi nRT over 60, is also on your formula sheet. So guys, what's important? You will be able to calculate any of that. Right, Brady, good question. Is the part which pops up now. By default, all motors are a 4-pole motor. In other words, 2-pole pairs. So by default, except if the question states it's a 6-pole, 8-pole, 12-pole, 16-pole, 24-pole motor. But by default, all motors are 4-pole, 2-pole pairs. North-south, north-south, it becomes 2 pairs. Is that clear to everyone? 2 poles, pairs, in this case, if it's a 4-pole motor. So please remember, if I don't tell you how many poles there are, by default, it's a 4-pole motor. Right, let's look at the questions. Now, guys, I'm going to give you about 10 questions we're going to look at. And I'm going to go through them. And I'm going to share them with a formula sheet. Once I've done this 10 questions, we will take a couple of minutes break. We'll come back, and then we're going to do about 10 questions together. And then I'll leave you to go and practice all this calculation questions. So please take note. If a motor question is given, and important about this whole situation, they don't have to give you everything, is to make note that the question says synchronous speed. What's meant by the term synchronous speed? Synchronous speed is the speed in which the magnetic field rotates in the stator. Please take note. If you don't know, you're not going to remember. Synchronous speed is ns. This ns is the synchronous speed. Now, if you look at that and you're going to say, what the hell does it mean? You're going to tell yourself, hang on, the formula is frequency times 60 over pole pairs. If you don't know the formula, bring up your formula sheet and there's the formula. NS equals 60 FP. Please take note that the F is your frequency, your P is the, any guess? Pole pairs, guys. Very important, the pole pairs. So remember, if I give you a P in this formula, it's the pole pairs. So Brady, by default, how many pairs or how many poles does this motor have if there's nothing written on the nameplate? How many poles? Not pairs, how many poles? 1, 2, 3, 4. Yes, well done, 4. Right, so let's put in values. Frequency, 50. Except if they give it to you different. Well done, Godwin. If I say to you, what is the amount of poles? Pairs. Then you're going to say 4 divided by 2. That's important. And yes, Godwin, you got 750. I get 1,500. Please take note, do not divide it by 4, but divide it by the pole pairs. So Godwin, please make sure that you use the pole pairs. Brady, well done. So guys, if you type stuff, I can see it. Please talk to me via, or just talk to me on the speaker. I'll be able to hear you. So it's very important for you to know that a motor, if the poles was not given, it's a 4-pole motor, but in the formula it's pole pairs. So to recap this question, the formula sheet is there. They want to know what synchronous speed. You must know that NS is synchronous speed. So guys, if you got this formula sheet close by and you've got a highlighter,
Hi, Mario.
highlight the ones to do with motors. You will get used to them. So eventually you will know exactly where they are. So that is the first calculation.
Mario
Now
is
in the exam, they can ask you what is the synchronous speed of a motor or an alternator or a generator. It doesn't have to be a motor. It can be an alternator, pink with white dots. It can be a generator which has got a green muddy color sitting in the ceiling. They don't see, they can give you all that other questions, but it's important. By default, 50 hertz, except if they give it to you differently. Secondly, the poles which is given by default is 4 divided by 2, and you know what the pole pairs are. Gentlemen, ladies, this question you will get in your exam. Maybe one of them, maybe 2 of them, even sometimes 3 of them.
Hi, Marius.
Right, let's try the next one.
Marius.
The next one is slip. What
Hello,
is
Mario.
slip? Slip is the percentage difference between rotor speed and synchronous speed. There's a formula for it. I'm going to put the formula down because synchronous speed is, sorry, try again. Slip is synchronous speed minus rotor speed over synchronous speed. If you guys look nicely, they want it in percentage, and slip is always given in percentage, so you must multiply it with 100. So there's my formula sheet. Now, where is it? Let me have a look. Let me put my glasses on. There it is. Percentage slip is synchronous speed minus rotor speed over synchronous speed. Look, they even add the 100 for you guys. So let's have a look, Panama. What is the percentage? So firstly, what is the synchronous speed? We don't know, but we know what the rotor speed is. There we are, 1,440. So there's your rotor speed, 1,440. What's my synchronous speed? Elno, where do I get
4%.
my 2? Is it in a previous question or on this question? Thank you, Graham. The 2 is the pole pair. So by default, I'm going to bring it up now to work out synchronous speed. Frequency times 60 over pole pairs. Remember, by default, the motor's got 4 poles, if I don't tell you. And for the formula, you have to put in pole pairs. So you take the 4, you divide it by 2, and you get an answer of 1,500 RPM. You replace that. Remember, that is your synchronous speed. Rotor speed, 1,440. Your synchronous speed, 1,500. You put that in, and now here comes the magic thing. You put that in, and you work it out. And Godwin, well done.
4%.
4% slip. Now, guys, that tells me your stator and rotor has got a 4% difference. But now I'm going to teach you a big issue we have in exams. In the exams, they don't always ask you the slip of the motor. They ask you the speed of the slip. In other words, what is the slip speed? The difference between the two. And the difference between the two is synchronous speed minus rotor speed. And you will say 1,500 minus 1,440 give me 60 RPM. So your slip speed is 60 RPM. Be very careful. Some exams, they ask you the percentage slip. Some exams, they ask you the rotor speed, the slip speed. In other words, what is the speed of the difference between the two? In this case, it will be 60 RPM. Is that okay for everyone? Godwin, it looks like you managed to work out the percentage. Well done. 0.4 times 100. So Graham, just to confirm, in the exam, they can ask you the percentage slip, where there's a formula for it. NS minus NR over NS times 100, which will give you the 4%. Or in the exam, they can ask you, what is the slip speed? So gentlemen and ladies, you must probably still have to work out the synchronous speed. Your rotor speed will be given, and you subtract the two from each other. Now guys, if they ask you this one, and you have to work this out, it will be at least a 2-mark question in your exam. So what else can they ask there? Well, not much, because you must be able to work out synchronous speed. Rotor speed is given, and there we are, work out slip. Not too hard. Practice this, and you'll become perfect. You got 5 more weeks to practice this. Right. So now we talked about speeds, the synchronous speed and the rotor speed. Now we're going to talk about a little bit about frequency. Well, firstly, you must know that the stator has got a constant frequency, and that is 50 hertz. So the stator has got a constant speed, the synchronous speed is constant, 1,500 RPM. The rotor is turning 1,440 RPM. Little things you must know. When I start the motor, the rotor frequency will be 50 hertz. That's important. So when you start the motor, the synchronous speed's frequency stays 50 hertz regardless. The rotor frequency, when you start the motor, the rotor still standing still, is 50 hertz. But as the motor goes faster and faster and faster, the rotor speed will drop. So firstly, you must know the slip of the motor. Because we worked out the slip was 4%, the difference between stator and rotor, right, in percentage, you take 4% of 50 hertz and full speed, your rotor frequency will be 2 hertz. What I try to say is your motor rotor frequency will start at 50 and it will drop down all the way down to 2 hertz. But when it hits 2 hertz, that means your motor is running at full speed. As your motor will slow down, your frequency on your rotor will become higher and higher. And if your rotor frequency is run about 25 hertz, it means the motor is running at half the speed. And that's where speed drives came in. It plays around with that frequency. So they can ask you this. I believe they have asked this before, where the question in exam will be at 3% slip, 4% slip, 2% slip, what is the rotor frequency? So all what you need to do is take that percentage, and that will determine how many frequency is on the rotor. A little calculation, guys, not too hard. So just to show you, when the motor starts, the rotor is at 50 hertz. As the motor goes faster in speed, the frequency will drop. There it's 2 hertz. But as the motor goes slower, the frequency will go up. When it hits 50 hertz, it tells me it stops, and boom, motor switch down. So that is just a bit of a graph to show you the frequency on the rotating part, the rotor. Important, the frequency on the stator is constant 50 hertz. Right, question 4. What is output power? Now, we're going to talk about output power now, as well as input power. Now, again, I told you earlier, there's a formula for that. And output power, because this is a 3-phase motor, look, three-phase, there's a √3 involved. So we've got √3 VL IL cos theta. But I tried to push you off track. What is that? That is output power. So as easy as what is on the nameplate. That is your output power. You don't need to work it out, but in this case, it was given. There could be questions where you have to say to yourself, voltage, obviously root 3 times voltage times current times power factor times efficiency will give you your output power. In this case, we can't because the efficiency was not given. So if I need to work it out, there could be a bit of a formula there. The formula is not 100% perfect. You guys, do you want to let Clayton in? There. Is it? Clayton has joined us. Right. So take note. If everything was not given, there could be a formula. But this is also options. There's two formulas I gave you. So the one formula could be P output is 2 pi nt over 60, or output power, efficiency, input power, and you can transpose that formula. Or alternatively, you can use this formula. Now this formula is not on a nameplate. It's nearly there. Look, P equals root 3 VL IL cos theta times efficiency. The efficiency will give you then the output power. So let's have a look. Voltage given, current given, power factor given, efficiency, oops, not given. So that tells me I cannot use that formula. So can I use this formula? 2 pi nRT over 60. Right. If nR was given, yes, but the problem is torque was not given. Now because torque was not given, I cannot use that formula. So guys, there is so many formulas. Just get the right one to use it. Cool bananas? I hope so. But in this case, very simple. We're going to try something like this later. But at this moment, all I want to share is if output power is given, take it from the nameplate and tell me what it is. Output power of the motor. Calculate the output if a horsepower was given. Right. If you have a look there, the horsepower is given. How are you going to make this output power in wattage? Right, guys? I think you guys could recall. We're going to say, can anybody remember? We're going to say 746 times 5. Oops, sorry, I'm just typing it here on the chat show. Times 36. And there we are. And that should give me an answer very close to, yep, you're right, 4,000 watts. So please take note, and I'm going to say this very loudly to everyone. In the exam, don't round it off. Write down the value on your calculator. Godwin, well done. That answer of 3998.56 or 57, you type in the exam, except if they force you to round it off and there's no decimal points. So please, there will be a tolerance. You will not be caught. This is not hard. Be careful if the horsepower was given. So 4,000 divided by the output power of 4,000 divided by 746 works back to horsepower. Sometimes they can give you 4,000, guys, and they ask you what is the horsepower. So you take 4,000 watts divided by 746, give me 5.36. So they can swap it around and ask you that. So just know it's not too hard. Right. Input power. What goes to the motor before losses? So we said that there's losses, iron losses, copper losses, windage, bearing losses, or friction. Now, when you take all that away, we get 4,000 watts output power on the nameplate. How do we going to calculate input power? So guys, all I need to do is take the values. And please take note, I said in delta. Delta is according to that configuration. So there's your formula. If you don't know where it comes from, there it is. P equals root 3 VLIL cos theta this top one. Or you can use a single phase one, but there you have to do a bit of a calculations. I will not do this one. I'll rather use the middle one. The bottom one will confuse the hell out of you guys. So, very important. Root 3 is given. It's 1.73, right? V is your voltage, 415. I, 8.52. Cos theta, 0.82. Now, guys, an alternative formula, you can use this one, but you have to transpose. The problem is output power is given, 4,000, but efficiency was not given, so I cannot use this nameplate. So there we are. Voltage, 415. Current, 8.52. Power factor, 0.82. I'm not going to carry on. I'm going to do that. I want you guys to type that in and see what you guys get. I'm looking for some answers on the chat room, typing room. I would like to know what is the input power of this motor. It's in the 5,000s. Godwin, 79.6. Just retype that out. I got root 3. Panama, that looks good. Godwin, N. Here we are. Gosh, Josh, yes, great stuff. Now, I got to answer 415. I got to answer 5,021. Look what I get. Anything between there and there should be okay. I know some of you guys said 5021.83. That's fine. But what I try to prove the point is, if you use 1.73, you will get a different answer if you say the root of 3. Your calculators will give you a different answer. The good thing in the exam is the examiner will accept any of that answers. And I'm going to say that again. In the answer sequence, they got a tolerance. If you have to type it out, the examiner will pick that up, and the computer will pick that up and will accept that answer for you. So very, very, very important. All those who helped and typed in an answer, fantastic. Jonathan, Josh, Dirk, Godwin, Parama, Godwin, Graham, Maria, all of you guys, well done. I really want you guys to remember how to type it into your calculators, because sometimes your calculator can be tricky. Now, as I said, you got 5,021 and you got 4,000. The difference between the two is your efficiency in wattage. The difference between the two will give you a percentage. I'll work through that now, but the first one is share. Can you work out input power in delta? If you can, I'm happy. What happens if some smart asses ask you, what is the input power in star? Now, I can't recall if you guys did or listened to my videos of my first 2 sessions where we did supply. Could you recall I said to you that in star, the motor is 3 times weaker than delta? And in delta, the motor is 3 times stronger than star. So in this case, the current is 1/3 of delta. So you take the current divided by 3, the voltage is the same, or you take 8.52 and take note the voltage. Now you're going to type it in, you do a calculation, and there it is. So if you take 5021 and you divide it by 3, you also get 1671. So in this case, guys, the motor in star is 3 times weaker than delta, or delta is 3 times stronger than star. But please take note, if I rewind this up to there, that is most probably your common question. I just thought I'll share this with you to prove to you that in star, your motor has got 1/3 of the current as in delta. Remember that. That might just give you that 1 mark to give you 99% or 61. Cool. Input power. It's not hard, guys. I'm going to say this again. This formula is on your formula sheet. Look at this video. If you're on this page and you can't remember, rewind a bit till the formula sheet comes up and then you'll see it. Alternatively, have the formula sheet next to you and see what it is. Cool. Okay, what's important now is it all depends what's given. This is a typical 2 or 3 mark question in your exam. They ask you, what is the efficiency of the motor? How effective is it? In other words, is it 80% effective? In other words, there's 20% losses. Is the motor 90% efficient with 10% losses? Now, let's read the question. The efficiency of the motor in percentage. Right, how are we going to do it? There's a formula. Efficiency is output over input times 100 to get percentage. There is the formula. So gentlemen, ladies, it's on the formula sheet. Again, we've done this one, we've done this one, we've done that one, we did a couple, yeah, we did star and delta. So take note, we chop around all the formulas. There's not many left, which we're going to do. We're only going to look at this one later. Then we've done all of them. We did slip, we did this one, we did this one, we did this too, and we did a couple out of this. So guys, get used to the formula sheet, practice it, because you're going to get the same one in the exam. So when you get this question in the exam with 2 marks or 3 marks, they're going to ask you, what is the efficiency of the motor? You're going to go and tell yourself, well, efficiency I have to work out. The output power is given. The input power is not given. So there we are. We're stuck. How do we work out the input power? Well, guys, in the previous question, I just showed you how to work it out. There it is. √3, which is the voltage, times the current, 3-phase √3, times the power factor, give me an input power. Now, you might use 5021. I just use 5015. Now, if you do your calculation, yes, motor is around about 79.75% efficient. Now, the exam can ask you 2 questions. They can ask you the efficiency of the motor, in other words, in percentage, or they can ask you the wattage which is lost. In other words, the wattage between the input and output of the motor. That is the total losses. So then what you do, you take the input power, and if you would have got the answer of 5021, you will say 5021 minus 4,000, and that wattage you get there, that is your wattage in losses. Again, they can ask you in the exam, what is your efficiency in percentage for the motor? Or what is the losses in watts? Don't confuse the two as well in the exam. Remember I told you guys earlier, what is the slip or what is the wattage, the speed difference between the two? That was question 1 and 2 and 3. Now at question 7 is the difference between output power and input power in wattage, or the percentage efficiency of the motor. In other words, this motor is 79.75% efficient. So this motor has got 20.25% losses. Guys, we are nearly there. Don't give up. What's meant by torque? Torque is the strength of the motor. How strong is the shaft in Newton meters? Now, we all know this formula, 2 pi nRT over 60. There it is. But be very careful. You just see an N. That is your rotor speed. Rotor speed 1440. NR. Your P exit is your output power. Now, guys, the difference between this one and that one is a name or a thing called transpositioning. Please try to learn how to transpose power output to torque. Alternatively, from tonight till next week this time, every day, 3 times a night, you're going to quickly learn that formula. till you can get this right. Gentlemen, ladies, students, you will see that in the exam, this question will come up. They're going to ask you the torque. Now, number one, the output power, the torque is what we're going to calculate. The output power is given. The rotor speed was given. Can anybody tell me and type it out for me? What is pi? What is the value of pi? It's not that movie you saw on Netflix. What is pi?
3,16, 3,14.
3.6017.
Right, pi is
3.14.
it 1.73 or 3 point? Can anybody remember?
3.1617.
3.14.
If you type it in your calculator, pi 3 point. I'm gonna guess. Is it 3.142?
Yeah, 3.142.
Isn't pi 3.142? Uri, well done, mate. Ravi, you guys are clever. Well done. Now, what's important? Your calculators, some of them has got it. Josh, you hit it on the nail. You just worked out the torque. So can anybody put that in their calculators and just see what they get? 4,000 times 60, close bracket, divided by 2 pi times 1,440. Should give you an answer. The answer must not be an error. If you get an error, you lost your bracket somewhere. Can you all see the answer is 26.52 Newton meters? Right, Brady, Dexter, Josh, Jared, all the guys who are typing the answers incorrect, which is 100% correct, you're going to get this calculation in exam. And guys, please do not get this one wrong, because this is a 2, sometimes a 3-mark question. Come and tell you why it can be more marks than normal. If the output is not given, then you have to take the voltage and the current and the power factor and efficiency or the horsepower and get output power. Normally it's given, but if not, you have to work it out. For the rest of you guys, this is a very, very, very important question in your exam. Right. Here comes most probably one of the toughest questions, because this question is in my handbook. This question has been asked for one trainee. I haven't heard about any other trainees got it, but you can get this one. The question is, if the voltage dropped by 5%, what percentage is left? Can anybody type the answer in for me? If the voltage drops by 5%, listen to my words, what percentage is left? Don't say 415. If I give you 100% and I minus 5%, what percentage is left?
95.
Well done, 95. Great stuff. Guys, another scenario to see if you guys are listening. If the voltage dropped by 20%, what percentage is left?
80.
If the voltage dropped by 20%, well done, 80% is left. So guys, when you're going to do this calculation, you use percentage what is left. It's a very tricky one. So you guys must probably know that the voltage is 415. So if this motor drops by 5%, the voltage will be left as 394. We don't care about the voltage. We're more concerned about the 95%. So guys, there's a formula. Voltage squared times torque. Now please do not use the voltage. Use the percentage voltage. So what you're going to do, you're going to say 0.95 square, because there's a 5% drop, times 26.52, and that tells me the motor is going to have a torque of 23.93 newtons when the voltage drop a little bit. Last week I said to you that we have a no volt relay in a system. So as soon as the voltage drops too much, the power must switch off. Otherwise, if the voltage drops, the motor is not as strong as it used to be. So guys, I just did this one. I want you to ask if the motor voltage dropped by 20%, or in other words, 80% is left. What is the new torque? Can anybody try that one for me and type in the answer? I gave you a bit of a start. I said 0.8 square times the torque. Give you an answer. If the first one comes up, I'll tell you what it is. 16.97, possible. 16.97. Panama, well done, mate. Jonathan, well done. You guys are fast. Godwin, you know what? If you guys can do this calculation so quick, you guys can do the theory exam in 2 hours flat. So guys, what's important? In the exam, they will tell you if the voltage dropped by 5% or 95% is left. What is the new torque? Now try this one, 16%. The motor dropped 40%. 40% of the voltage is gone. What is the torque? So you guys can work that one out.
9.54.
Well done, Jonathan. Man, you're quick on your calculator. 9.62, 9.55 roughly. Well done. Right. And one more, just one more. What about at 50%? If the voltage goes half from 415 to 207.5 volts, so the voltage drops, what will the torque be now?
Marius, where's the
6.63.
where's the equation for this one?
6.66 roughly.
Marius?
Cool, bananas. So guys, what I try to share with you, as the voltage drop in percentage, can you see the motor gets weaker and weaker and weaker dramatically? When it drops a little bit, no problem, but as it drops more, the voltage at the torque goes lower. Have a look. All what I did in this graph, I dropped the voltage a bit, but look proportionally how the torque drops. So what you need to take home from this is to tell me what is the consequence if voltage drop. And the answer is A, the motor will go faster, or B, the motor will lose its strength and eventually burn out. The answer is B, the motor will go slower. Because of the voltage, it will get weaker and burn out. Well done, guys. So very, very important in this question. As the motor drops voltage, you must always remember. Marius, I think you muted. So gentlemen, I'm not muted. I apologize for that, Jonathan. I can't hear anyone. For some reason, my computer cannot pick it up. I restarted it. I tried everything. Once we can have the smoker after this question, I'll restart my computer. I'll see if I can get it right. And then I'll answer all your questions. So guys, I'm going to answer your questions shortly, but I just want to finish by this question. If the voltage drop by percentage, remember to use the percentage what is left. Multiply that with torque, and that will tell me what the out torque on the shaft will be. Here is a proof. Okay, now guys, this formula is not on your formula sheet. So Josh, you must learn this formula. V square T. V square T. There it is. I put it in a note. V square T. Now that voltage is the percentage voltage. Now this formula is unfortunately not on your formula sheet. So I want you guys one formula to learn, only one, and then one transpositioning. So after Smoko, we will do that. I will ask more questions just after this because I'm going to stop the video and we can then regroup after that.